Okay, good. So yeah, we we have to wait for 3 more minutes. So it's till 10 o'clock. So then we can start a presentation. So yes, the other guys in the meeting room, can you introduce yourself? Neboisha. Sorry if I say it wrong. I am very bad with names. Neboisha, can you hear us?
It is good pronouncing.
Really? Thank you so
Yes.
much. But I can't pronounce every. I mean, some are even hard for anyone. I mean, so I wanna say, raise their hand. Okay, I saw someone raising their hand. Okay. Anyways, so Mr. Eric Rosendahl, can you hear us?
Yes, I
Hi.
can.
Hi, welcome to the Wastewater Talk. Can you introduce yourself to the group, please?
I can. I am Eric. As said, I study robotics engineering at STU University here in Odense.
I'm sorry, where?
STU.
Okay, in which location?
Denmark, Odense.
Denmark. Ah, okay, in Denmark. Okay.
Yes. And I'm interested in drones, so I thought it would be nice to join.
Good. I mean, I think you are in the right place if you're interested in drones and inspection.
That's
because
good.
in front of you is the guy most experienced who I know who can in this drone thing.
Yes.
So yeah.
Cool.
So I hope you can learn a lot and maybe share it to your friends next time and then visitors next time too. And yeah, thank you so much. Mr. Stefan Rutka. Hello.
Hi, good morning, everybody.
Good morning. Can you introduce to the group, please?
Yes. Hi, my name is Stefan Rutka. I'm from Germany, near Nürnberg, and I work at Inch Plus. I'm there. My area is marketing and sales of sewer services, digital sewer services in the area of B2B enterprises for infrastructure management.
Ah, okay. So is it your first time in the Wastewater Talk?
Yes, it's my first time.
Okay. So I hope you enjoy it and then you can learn so much. I mean, from today's talk episode.
Yes,
We move on to the next one. Mr. Balasas Borle. Sorry, I mean, I'm very bad at names. So can you introduce yourself to the group, sir? Hello.
Hi, how are you?
Hi.
I'm just familiar with some of the monitoring technologies and was just interested what's the latest.
Okay. So I think you're at the right time, at the right place. Thank you for joining the Wastewater Talk. Can you guys hear me? Okay, perfect.
Yes.
Because I'm having a problem with my microphone, but I hope it will be gone. So, yeah. So now we are 10 o'clock. So I think officially we have to start, but I would like to give 1-2 minutes for the latecomers. So, yeah. If anyone want to introduce themselves, this is the time, guys. So I see some, Mr. Philip Grimm. Hello.
Good morning.
Morning. Hi. Can you introduce yourself to the group, please?
Of
Welcome
course.
to the Wastewater Talk.
Yeah, hi. My name is Philip Grimm. I'm from Freiburg. I'm a hydrologist and founder of Grimm Water Solutions. What we're doing is software as a service for the water industry, mainly intrusion prediction, sewer control, etc. Yeah.
Oh, okay. So it's your first time in the Wastewater Talk?
No, I participated several times.
Ah, okay. So I think you are well known how this goes and what's the theme of it. Welcome to the Wastewater Talk again. So I hope you learned so much today with everyone. And so moving on. Okay. Mr. Webb Krieg. Can you hear us?
Hello, I can hear you.
Hi. Welcome to the Wastewater Talk. Can you introduce yourself to the group, please?
I can do, yeah. I'm Craig. I'm the sales engineer for Civico Environmental.
Ah, okay. So is it your first time, Mr. Krieg?
This is my first time. Currently, I'm just sat in a restaurant at a hotel, so apologies for any noise in the background.
No worries, no worries. Just turn off your mic and then it would be fine. I think it would be good.
All right, no worries.
Yeah. So we have
Hello,
our
guys.
co-moderator Klaus. Hi, Klaus. So he's also one of the organizers of this Wastewater Talk, and
Hello.
yeah, Klaus. So it's almost past 10. So what do you say we start this thing?
We started. Siki wanted also to join us, but her car broke down.
Okay.
The rental
Yeah,
car
she
she
wrote me,
got,
yeah.
so she's not in the office yet. She will join us any minute, hopefully, or something. Raghu, you are the champion then today.
Yes, I'm the leader.
Yeah, you're the leader. And then Simon will rock the show today, I think.
Yeah.
Right?
So, yeah. So before we start, I just want to say welcome to the Wastewater Talk, guys. So if anyone who is coming here for the first time, I just want to introduce a little quickly about this thing, and then I'll give you a small. You guys can hear me? Hello?
Hello.
Yep.
Yes.
So you guys can hear me? Okay, great. So the Wastewater Talk, it's about the exchanging knowledge to all around the world to see how the innovations and technologies are, what are the present situations and how are we going to manage it from the different parts of the world, and what are the solutions for the problems from one part of the world, and how can we find solutions from the other part of the world, or learn about new technologies from the other side of the world, and see how the modern day water and wastewater technology is improvising or evolving. So today, I just want to say a few minutes about the Wastewater Talk and to see how everything is. And then I will give over to our guest, Mr. Simon Kum. He's here from the company Inspect Drone. So he's going to explain us today. He's going to explain us today about the Wastewater Talk and the drone and how the inspections are going, how it evolved in the past years, and what's the present updates now. So first I want to share my screen. So I hope you guys can see my screen. So this is the episode 13 of our Wastewater Talks. And today the topic is outlook of Futural Sewer Inspection Technologies, like how the sewer inspections are going on and what are the changes and future changes it's gonna take. And so a small intro about Wastewater Talk. We have a new topic for discussion every month, and we exchange the knowledge in wastewater, and it's mostly for the passion of sharing. Like, if you want to share something, you are always welcome to join us and reach us by LinkedIn or through phone or email. If you have some awesome technology you want to present to the group or want to share to the world, then this is your chance. Please let us know, and then we will definitely find something with you, and you can be the one presenting next time. So, and it's also a kind of a meeting which you can know each other, like all the different parts of the world, like from different technicians to different companies and different technologies all around the world. So like I said, these are all the topics which we had for the Wastewater Talk from the past months. So from the, actually it started almost like 13 months ago. So every month we do one on the first Thursday of the month. So if you missed any of our topics before and it's your first time, and I'm saying it again, like if you want to see the Wastewater Talk episodes, please do go to our website or go to the YouTube and just type in Wastewater Talk, and then you will see all the old great episodes and with huge discussions, and they're very knowledgeable, and I hope you won't regret that. So today, as you can see, today is episode 13. It's called Outlook of Futural Sewer Inspection Technologies. And so today we are going to talk about the drones and the inspection technology. And the next episode will be on 1st of December. It's about the wastewater operators and how wastewater plants get to every day, and what is the life of an everyday operator and what does he do to keep the system running without anything going down. So a small introduction about our company. This Wastewater Talk is sponsored by created by the company Unitechnic. So we are a company from 1990. We started as an engineering office and then with plannings and everything. And from 2000, we started producing our own products against smell and corrosion and all the kind of things in sewers. And we also have so many other tasks and like sewer inspections, what we are going to hear today. And we also have the a software. We created our own software to calculate the sulfide in the sewer systems. And we also have a products against odor and corrosion and for the extraneous water like rainwater, which is avoiding to flow. And then we also have a rat control and all the things. So this is all mostly some of the main aspects from our company. So today we are going to do Uni Inspector, which is by Unitechnics. It's also doing the drone inspection together with Inspect Drone. So now I would like to give the stage to Mr. Simon Kum. So he's going to show us what he got today. Simon, it's all yours.
Hello, everyone. Great to be talking. So many interested people from so many countries. I hope you can all hear me. Quick feedback. Perfect. All right. Yeah, I'm glad to show you a bit what I've been doing with the company Uni Inspector in cooperation with Unitechnics for the last, I think, 2 years already.
I think 2 years, yeah.
Time is going by too quickly, definitely. Yeah, I will go share my screen in a minute. The thing fingers that works instantly.
Well, the internet is always a bit cranky sometimes.
There it should be.
Yep. Yeah.
Yeah. I'd like to speak a bit about what we've been doing in the past 2 years. Show you a bit of what's new right now, and yeah, I'm pretty sure we will also get to the aspect of what will come in the future. I mean, it's the topic of today. So yeah, I think that's something where also, of course, your input is highly valued. What do we expect in the future? What do we want to see? What do we think at the moment is technically possible? So, all right, let's dive right into it. Showing you a bit of basically our everyday work. Okay, now I just need, the presentation to start. Well, what's the idea of using drone technology, especially in give you an idea how that can look. A really nice image that shows, why we are doing it. We don't want manned entry into the sewers. You're probably all aware of the potential risks. When there is water, there is always the risk. There are gases, and well, it's a confined space. So the kind of obvious solution is to send in a robot. And what we can make out of that, I just want to give you a few impressions like this. I mean, you can, it's not a moving image, it's just a still image, but you can imagine the water flow on the bottom. It's not something where you want to or you even can stand in. So it's a perfect place to fly a drone in. And the image that you see here, that's actually well, it's a real world image taken by the drone. It's not staged or anything. 100% of the lighting is done by the drone. So yeah, I think that gives a good idea of what's possible at the moment already. Some more nice images, I think, what the world underneath Germany looks like, at least in some towns. All kinds of different profiles here. All kinds of challenges, of course. Not the easiest way to bring a drone inside the sewer. Not the easiest place to fly around. As you can surely imagine, there is, of course, no GPS assistance. So the drone relies at the moment on its sensors, distance sensors or optical sensors. I will get into the technical details of the technology that we're using in a bit. Just wanted to start with some impressions, get you unintended into the flow. Doing inspections at the moment down to, or starting at 800 millimeters diameter. There's, well, basically no on the upper end. Yeah. Get to see some places that are quite interesting, I would say. Really interesting, all kinds of places. So that is the let's say the current possibilities, or what we've been doing for the past 2 years with the drone that we have at the moment, or the drones. Just realizing that I forgot to put in the specs of the current drone, but yeah, maybe some of you have had some contact with drones in sewers or drones in industrial assets. You might have heard from Liability. It's a Swiss drone manufacturer. They produce specialized drones for indoor inspections, and at the moment we use for the images that you've seen here, we're using the Flyability Helios 2 drone. It's highly specialized for these confined space environments. It's from our experience so far, it's the best drone on the market at the moment doing these tasks. There are actually others coming up with new products, but it's still a very small market. It's a very dynamic market. There's lots of development, and well, the latest I'm going to show you. It's not so sure how many there are coming. What is the specialty of the drones that we use is that, as I said, they do not rely on any external reference signal, so there's no GPS obviously underground. They only rely on their own stabilization mechanisms. They only rely on their own onboard lighting system. So obviously in the sewer, cannot switch on the lights. So yeah, the drone does all the lighting itself. It's recording 4K video, is usually higher quality than everything we get in inspections. And of course, one of the main advantages of using a drone is it's flying, so you can go exactly where you want to go. You do not rely on anything driving on a given ground. So also when you have like bigger structures, not duct itself, but like rainwater retention basins. What you can see right here on the image, there's just a just an underground. Sure, I'm not too deep into the terminology, so feel free to correct me the specific wastewater terms here. So yeah, right here, for example, in this image, we've been flying through the egg profile canal here into this large construction. You can surely help me out. How do you call this? Bauwerk, German. So
I don't understand you. Can you
sorry.
repeat?
How do you call Abwasserbauwerk in English?
Yeah, it's wastewater structures, like which is underneath the sewers, like the structures for holding the just like storing the capacity, like the construction work which is beyond the sewers, which is high profile constructions, like something like to be frank, like if you have a mixed canal system, so your
retentions for
yes,
the
your rainwater retention basins.
yes.
So these kind of things have huge structures which are built underground in the sewers. So these kind of structures need inspection because people want to know how it looks like now, and after a few years of construction, they just want to know what are the damages inside and how it's corroded or how does it even look like. And some of the things they can't even just send a man in and send a instruction. I mean, just to inspect it, because they are huge structures, and then they also have a huge potential risks and safety risks and hazardous risks. Suppose if it's a sewage and a mixed system, so you will have a risk of high levels of H2S, hydrogen sulfide, and you can always have if it's high levels of H2S, then you can't send a man down because it's a dangerous gas. So in that kind of things, we mostly send drones, and not only because of the safety and because of the precision. And in some projects, what we have customers asking that the structure is like I don't know, from so many years old, and the plan is like outdated. They don't even have a particular plan for this project, and some are before the World War II, like so old. So the structures, so these needs to have a new plan. They want to have a GIS data, and then the plan which they can see all the measurements. So something like a 3D, 2D pictures, and some kind of which they can be used to make a report, or some kind of to activate or restructure like the structures or the basins. So in these cases, mostly we use drones instead of the people, so that these drones, like Simon said earlier, there are two kind of drones. One is Helios Y and one is Helios Tri. So from this company, so Helios Y is having a small diameter compared to Helios Tri. I guess Simon has the pictures later.
I will. I think it should be on the next slide. That's why I'm sticking with this
Okay.
image here for so long.
Okay, then
we'll
I'll give back to Simon. Sorry.
Thanks a lot for the additional information.
No problem.
Right, the underground structures is the word I was looking for.
Yeah.
Yeah. So in this case here, I think there's no possibility to enter directly into this structure here. Have to go through the egg profile here. All right, let's go forward and yeah, okay. There's something interesting as well. Obviously, we do inspections while the sewers are in operation, in full operation, which is also something that, yeah, well, it's one of the advantages of using a drone. You don't usually you don't have to especially prepare any of the sewers, or well, obviously not prepare them for manned entrance, so you can fly in under almost any condition. Sometimes you find things like here which do not make the operators happy, especially, but yeah, very valuable information, of course. I'm sure you already had the topic of Fremdwasser, or outside water entering the sewer system.
The extraneous water, which in the previous episode we spoke about some water, like it's called rainwater, which is coming into the sewer canals. If you have a split system, like one channel for the rainwater and the other channel for the sewage water, you don't want to have your rainwater coming into the sewage canals. Maybe if you see in the picture like here, you have some kind of cracks and everything, so it increases the water level in your sewage canals, so that the the amount of water which end up in the pumping stations and in the wastewater treatment plant, it increases dramatically on the rainy days, and which indeed you need to purify more water, which costs more energy and which costs more prices to purification and all. So in these kind of situations where you can see in this picture, there is a small hole or some kind of crack or in the structure or in the road. So the rainwater is escaping the road, and then through the cracks it's coming down to the sewage canal. So in these kind of things, if you send a drone in, I mean, you can't send a human in, or you can see it manually because the pipe is a bit wide enough, and then you want to have a particular pictures of it. So in this case, we send a drone in the canals, and then we can have a pictures like this and save a lot of water, and then see where in the structure we have a damage or how we can modify it. Yep.
Actually, in this case, it's even worse than rainwater. It's groundwater.
Okay.
Structure is below the groundwater level, right next to a small river, I think. So, well, you have continuous inflow of this extraneous water. Well, of course, increasing your cost and energy consumption of the purification. Very valuable to find these spots. Right. So one more thing that we are doing in wastewater plants is inspection of these fouling towers or fouling structures, fouling tanks. Once again, you don't need human entry. You don't need a scaffolding in here, as long as you don't do any mechanical maintenance. Just want to know, okay, is my structure doing well? Are all the screws in place? Are all the stabilization constructions, are they all in place? Is there corrosion or something? Yeah, we save our customers a lot of money by just flying in there and not needing any scaffolding. In this example here, everything was fully pumped out. We've also been doing inspections where you had like a few meters of sludge still inside. So of course, doing manually, completely out of the question, but emptying it even more would have been too expensive. So yeah, we just used the inspecting of the 80%, which was above the sludge line, and yeah, giving really, really good results here. Actually, the drone that you see here is the one that I'm going to talk about. Yeah, also a very good example, I think, why using a drone is doing very much for the safety of workers. Obviously, this tour here should not look like this. Yeah, it's pretty dangerous environment. Also here we have like a broken in part of the part of the earth around the sewer. I think it's a canalized stream here. And of course, we don't only want to find this, but we want to locate damages. That's one thing which started like 2 years ago. Technology made it possible to locate the damages in 3D models. what you can see right here is a combination of a photogrammetric model of the of the underwater of the sewer, which you see in the lower middle. So right here you have the sewer going under the road, and right here it is just what you've seen on the right here. So actually this damage, we've been flying even closer and look up, and it's almost going up right underneath the road surface. So here we combined this 3D model with image data from a drone flying on the outside. That makes it possible to have perfect georeferencing. So you can actually, with this point that is set here, can have the georeferenced coordinates. You can send someone with a GPS device out here and actually pinpoint the place on the road where this hole is. So you can, in this case, they went ahead and directly closed down the part of the road where the hole was, and started excavation, I think, the following week, to avoid any dangers of the road collapsing. And well, I think it also shows one of the great advantages of using a drone. It is very quick. So for all this project here, including flying several times into the sewer, flying on the outside, producing the 3D model, and actually getting the exact coordinate, it took like maybe 4 hours. So including all computer processing. The flying itself was maybe 25 minutes maximum. One really cool thing, just want to go because it just makes it so much more interesting. Get into places that are basically unknown. These parts of your sewer system that either nobody dares to go in, or so you find these interesting structures like this pipe here going right through the middle. Nobody really knows if the pipe is still active. In the same, I think, a few meters back here, there was a pipe which was not connected to anything. Always good to know what's underground. I think this one of the last examples from the old data, where we explored a World War II air raid shelter, which was accidentally found underneath the road. And as you can see, that's not a place you want to go in manually. Already broken down. Mostly you can see on the ceiling, it's the bare sandstone, or not even sure stone. It's more like compressed sand. Definitively not safe. All right, but we want to talk the latest technology, of course, and here we have the Helios 3 drone, which is the latest drone from the manufacturer Liability. We've been actually operating this since April of this year. We've been involved from the side of Inspect Drone directly in the development, so we had a bit of an early access. And what makes this drone completely different to everything that's been there before is mostly the payload. So this drone is constructed to carry payloads, and especially what we have right now is a LiDAR laser scanner module. This allows you various things. Most importantly, it allows in-flight localization. So you have a live 3D map of the asset that you're flying in. And you have the exact position of the drone inside the 3D model. This allows, for example, in the falling hours to exactly know where am I, where have I been before, so you don't miss any spot when you're trying to get a full coverage of the whole. Of course, you still have the high resolution 4K camera with a very wide field of view. So even in tight spaces, you get a good overview. It's really high image quality in low light. So even when the lighting is really challenging, you get brilliant pictures. The lighting is up from previous drone versions. So you can output 16,000 lumens. You can basically light up more or less any structure of common sizes. And the light is made dynamic, so you can tilt the camera, which is the red module here in front of the drone, and tilt it up or down, and the light will be directed the direction that your camera is pointing. I mean, obviously, as you can see here, sorry for not showing this before, but the general structure of the drones we use is that they are inside a carbon fiber cage. The cage is protecting the drone, but it still allows the drone to get in contact with the wall. So it's not a case that you must stay away from walls, and the cage is only like the glass barrier, but it's actually designed to like stretch along a surface or be in more or less constant contact with the wall without getting into any troubles. This drone here is actually IP44 protected, so picked for environments like sewers, where you tend to have water. Yeah, the propellers are ducted here, which is really nice, protecting the drone against any objects entering the propellers. So in these challenging environments, there's less danger of like getting any material into the propellers. And the flight time, we actually tested this. If you remove the laser scanner, you get flight times of like 12 minutes. So you can really fly for a long time, recording the video also while the lights are on. And now, I mean, what's interesting is, of course, with data. And yeah, I've got some examples for you here. The laser scanner allows you to do survey grade laser scanning. So you have very high resolution laser scans. The scanner is an Auster OS Pro-32 laser scanner. If anyone from that field, you probably know what it means. To everyone else, it's a industrial grade laser scanner, which is scanning less 150,000 points per second. So it's a 360-degree rotating laser, picking points in any direction. And yeah, what you see here is large, like a ducted stream. On the right side here, it's coming from outside. It's going underneath the road. You have entrance, manhole here. You have a bigger one right here. And yeah, with this data, you can really you can see it's not perfect here in this instance, but here there's a transition from one profile to the next. There's another transition right here. I think there's a transition hidden somewhere behind there. So it's the perfect tool for really surveying any constructions which are pretty old. But in this case, I think it is like built in 1910s or 1920s. And of course, you can imagine that the town above the construction here has changed since then a lot. Plans, I mean, they're still like the original plans, but you never know. So it's a perfect way to update your plans. It's from a rainwater retention basin, a very nice example, I think, showing how of the again is great advantage of have lots of pillars in here. If you would like to scan it manually, you have to place your stationary laser scanner in lots and lots of places just to get a good coverage of all the pillars. Also, there is like on the bottom here, like a dry weather duct where there's also always a little bit of water flowing. As you can hopefully see here, scanner even scanned the bottom. There was not a lot of water flowing, so it was able to pick up the bottom here as well. And that all was done in just one flight. So it's like an 8-minute flight. Complete scan of this here was done. That's an even bigger one. The big basin here, I've done a horizontal cut here to show the inside. It's about 1,250 square meters. All that this is completely done in one flight. The second basin here is done in a second flight simply because there's no direct connection that could be used. And I think we had a third flight. This part here, as the drone couldn't get through. Yeah, I mean, all in all, the complete scan here was a job of maybe 1.5 hours, including repositioning, etc. I think I've mentioned this before. With the 3D modeling comes also the great possibility to reconstruct the flight path. What you see in red here is the position of the drone at any given time. You can, the next slide, it's much better to see even. So this is the software that is used for tracking for making the drone data really usable. So you have on the left side the 3D model from the laser scan. It's optically not that nice here because not the latest version of the software. But still, you can see here in white, there's the position of the drone, and you've synchronized with it on the right side the image taken at exactly that place. So for the detection of any defects, you do know very exactly where is the defect. You can do measurements here, so it's all perfectly, the dimensions are all perfectly recorded. And you can also you can pick your place in the video down here, can pick any position, any frame that you want to see, and have the perfect connection to the position of the drone at the given time. Which is, of course, from everyone working with sewers, you absolutely need this. You cannot guess where the defect is if so. That was my yeah. Well, the things that we are doing right now. To give a little idea on what we think will be coming, when you at an image like let's take this one here, you're able to record flight paths we're all able to do perfect 3D scans of assets. So, of course, one of the targets for future inspections is that this does not need to be done by a pilot and fully manual, but you can program your drones. You can, if you take this instruction here, you can program that once, then you just repeat the flight autonomously. Not autonomously, but automatically. Autonomy then is, of course, next very, very big challenge that's coming up. I'm sure that everyone working with Zoom is crossing fingers for that to work, because the stewards, look at that. It's a really complex structure. There's a lot to find. It would be really nice to just like drop in a drone or whatever robot you want to use and tell it, go from here to the next opening, come out again, change the battery and continue on, or recharge the battery, upload your data. And it's actually, of course, something that's been worked on in various places, starting from the drone itself, and of course the software side. So at the moment, what is, I guess, is the latest technology regarding the automation is files AI through inspection software. So you've got input like the drone video data and the 3D model data, and then an AI software is automatically detecting like cracks and doing the full visual inspection, basically, that you usually have to do manually. All the coding of damages, and also the report creation. So yeah, I don't have any images from that. Not sure, Klaus, if you have images from AI system. Couldn't find any my computer, but from what I heard, it's so far. So I think that's definitely what will come more and more in the future. So automation of the inspection vehicles, drones, and of course also the automation of the porting and the optical. How do I put this? Yeah, well, the optical inspection. Yeah. So you don't have to work for. Let the computers work for you. That would be, I think, good for everyone, right? So yeah, that's it from me. Not sure how Raghu, did you find a way to activate the chat somehow?
Actually, not yet. I mean, the thing is, we need to create a new link. I mean, this link cannot be added with the chat option because this should be done before the video. So
next time, but
yeah.
of course.
So I promise you guys that next time we'll definitely debug the code, and then we will we'll add the chat box. But I was wondering if you can show one small video about how the drone is flying. Like, it doesn't need to be a big one, like maybe like 2 minutes if possible.
Yeah,
like
I
think everyone will be interested in that.
Yeah, sure. I will look for one. Do 1 or 2 minutes of talking. I'll be right back with the video.
Yeah. I have actually one video of the from the drone inspection which we did recently in Berlin. So let me know if you want something. So in the meantime, if anybody has a question, please, please to ask our drone expert, Mr. Simon Kum, and he would definitely answer your questions. So yeah.
I have to turn on the microphone. So just, I hope it's not too laggy, the transmission, but I'm just going to start this here and let you do a quick tour underground of EF Germany. There you can see on the ground the water flow is pretty high. This is the main sewer going to the treatment plant. Actually not too much to see here, except for sewer and a bit of spider webs hanging around. A little bit of ingoing here. I'm actually not sure about the dimensions here. Just for to give you a rough idea, it's about 2 by 2 meters. So it's not a perfectly round profile. Probably like 1.9 meters wide and maybe 2 meters 20 tall, something like that.
It's actually an oval shape. Something like this. It's not round, but it's kind of an oval shape.
Yeah. I think the bottom part is like it's round and the top shape.
Yeah, it's like an egg.
Like
if you see the egg,
parabolic. So yeah.
It's an egg shaped.
Yeah. All right.
Yeah.
So I think that doesn't get too much more interesting here.
But I have a video from the inspection from Berlin. Maybe I can show that.
Great.
Yeah.
Yeah, drone from the outside. Of course, here now we only saw what the drone is seeing.
Yeah.
But seeing the drone is.
So I will start from the starting of the presentation. And before that, Neboisha, you raised your hand. You have a question before I start my video?
Can you hear me?
Yeah.
That's cool. I'll try to send you information that chat messages are not working. But
yes, we are aware of that. Yeah. I'm sorry for the inconvenience. Yep.
Sorry, and I'm connecting by the phone. I want to thank you for this very good presentation. We are from Niš in Serbia, the water and sewer public utility company, and we are in the Department of System Analysis Department, which is responsible for CCTV inspections. Can you hear me?
You have a question for pilot?
Yeah. I have a question, which is I think everyone is talk about currently while you're watching your videos. Have you ever had a hazardous situation like the drone is droning, and how you pull it up?
Yeah, that's a question we get a lot. And yes, actually, we had a drone that got lost once, but it was actually a very stupid technical issue. There was a connection, a cable broke inside the remote controller. So I would say the technology of the drone itself is pretty much perfect. No issues there, but yeah. you can be unlucky sometimes. I know.
Then you have to go fishing.
Yeah, unfortunately, it was right before. Oh, I have no idea what's the word for dukkha. So
Dukkha?
Like where you water is going below another, like below a river or.
Okay, I mean, if there is a river flow on the top, and then if the canal is going below the river. So.
Yeah, right.
So that it's like a pumping canal in below the river flow, so river basin.
Not pumped. But,
I mean, sewage pipelines.
Natural flow. That well,
okay.
Let's say we never found anything off the drone again.
Yeah, that's risky.
Yeah,
then we need to go fishing.
Price for learning.
Yeah. Then we need to go fishing for that.
Great.
Yep.
But other than that, we have very good experience. Various environments.
Okay. So yeah, Mr. Peter.
I'm sorry. I'm sorry for interrupting. It was very interesting for me. We have also brick. Some part of the channels are the brick, but old one. This is also old one, but we didn't have enough money for the maintenance, and we have a problem with that. We have something around 10 kilometers, and we always had a problem how to inspect that because of the sludge on the lower parts.
Mm-hmm.
And this was very interesting for me to see this. This answer to this, the questions from guys from Niche, they said it was also something that I was thinking about, that how to find it if we have a problem. We have a big diameters around 2 meters and also smaller 500 millimeters. But this is interesting to see what are the current situation in the channels.
Mm-hmm.
This is something that we will also need to think about. That I think that we cannot hire someone to inspect that.
Yes.
From Germany, that is the certain thing. But maybe here or maybe to find this, because I see this drone is it's at some not coverage, but it is. I think it's built for this kind of work. And it was very nice. I wrote down the name, Ilias Free, and I already looked on the internet. Thank you. I'm raised my hand because of this, because I need to go and I want to thank for everything today. It was very nice for me to see this. Thank you.
Thank you for participating.
Thank you.
I hope we see you again.
Me
Thank
too.
you, Mr.
Bye.
Peter.
Bye.
So yeah, now I'm going to show my video, like for a few minutes. So just want to show them how it's from the recent inspection in Berlin. So I hope we have some questions after that. So I want to share my screen. So yeah, so here, can you guys see my screen? As you can see here, the drone, we put the antenna inside the kennel. We need to do that first before in order to put the drone in, so that it gets the GPS and yeah, signal as well. So as you can see, this is a rainwater channel and a rainwater basin, and this actually goes into this to the small channel which goes into the river, which connects into the river. So this is actually rainwater structure, and the customer wants us to know how it looks like and what are the problems it has and what are the damages it has inside the pipe without sending a person in. So it's a big structure, and then it's actually it's actually square, like a box profile. The sewer is not round, and as you can see, it's like a box, and it also has a bit water in. So the thing which makes it extraordinary is this drone has a capability of finding the depth of the water. Like it can even measure inside the water depth. So it's like the water, I mean, you can see the 3D pictures, which comes even under the water, under the depth of the water. So it's like a new thing for us because we never quite imagined that it can do that. So here you can see some damages in the left, and then you can see the exact box structure, like it's a rectangular dimensions, and then yeah, we went through the drone, and then there is actually till the screen which stops the waste and everything going into the channel. So this is the wastewater collection sump, you can say, and then it flows through it. Yeah, so we went till the end, and then we went till the chain, and then we saw here you can see all the damages and all the corrosion and all this structural problems which you can see in the screen. And then we were supposed to, we got back, and then here you can see the damages as well as the slime and everything. So yeah. So that's a small video from myself. I mean, I made this video. I mean, I wanted to show this video so that you guys can have a more idea of how it's going. Hello?
Cool.
Can you guys hear me?
Yes, yes.
Yes, we can hear you.
I have a question when it comes to flying.
Yeah.
I was wondering how is it you would control it when it's down in the sewers? Is it like first person or?
Yes. So you have a direct video. You have a video link.
Which are sources? If you want to close.
You get the live video feed from the main camera for navigation. And when flying the Ilios 3, you also get the live 3D point cloud on a tablet attached to the remote controller.
Yeah. Okay.
It's like basically the normal drone which you have a DJI Maverick which goes on the screen on the air, but this also has a screen. I mean a big screen which is connected to your controls, where you can see the live video, and then you can stop at a certain place, and you can even control it with your remote control, and you can change the flight path and everything, and then you can go up and down and then move in which direction you want to, just like a normal motor car. Like you control it from the ground, and then you see what's happening down.
Okay. Cool. Thanks.
Yep. So any more questions?
I think looking for a video actually.
Okay.
Show it quickly where you can see the drone starting.
Mm-hmm.
Giving an idea what it looks like. So this is the Ilios 2.
Ah, yeah, that's how it looks like. Right.
Starting on the outside, the cable that you can see lying on the ground is the antenna extension going down, and well, yeah, drone is just flying through the manhole here. And from that point on, you only have the possibility to steer it by looking at the live video, FPV video.
Yeah, exactly. So,
which is actually not that easy.
Okay.
I think you can
so
imagine.
Mr. Eshan Sabeti, he has a question.
I'm sorry because I joined late, and maybe my question was answered in the presentations. But if it's broken, or maybe how some problem with this drone, it's gone. I mean, how we should go and find it and something like that. And my second question is about how many meters, I mean, for example, from manhole to manhole, we have for example, 50 meters to 70 meters based on the standards, and does it can go for this 20 meters or not? Or does it have any sensors? Because maybe I made a mistake in doing with this drone. And is there any sensor, for example, to not come up and go into deck or something like that? Is there any sensor that control me too or not? Thank you.
Questions. So first of all, there is when you lose the drone, depends really a lot on the environment that you are in. So when there is a strong water flow in a very big sewer, probability that it's completely lost is high. I've heard of drones being lost in sewers that were recovered, where there was not that much water. The need for repair is pretty high then, of course, because water and electronics don't mix that well. But also the likeliness of it coming in contact with water is pretty low, I would say. I mean, as long as you have a skilled pilot, and you need a lot of training for that, definitively. Risk is low. Yeah, if something happens, better have some insurance. Be prepared. I think the second question was how far can you fly? That's actually highly dependent on the size of the sewer and certain external factors like can be the wind, it can be the like the water flow, whether the water is has a flat surface or it's very turbulent water. But as a rule of thumb, you can say in I showed an example of a 800 millimeter diameter duct. You can go about 30, 40, maybe 50 meters, depending on the conditions. When we talk about very big ducts, like we've been doing a 3,400 millimeter or 3.4 meter sewer lately, where we managed to go a bit above 200, 220 meters. So that's the range. It's basically not limited by the radio. It's mostly limited by the battery of the drone. But yeah, that's what you can expect. Something in that range. I always say that the ideal conditions flying actually is at least 1 meter of air above the water surface, simply because you can then get a good range. When you have an 800 millimeter diameter, that just limits the amount of water that can be to an absolute minimum. The thing is, just yesterday we had the case that we wanted to fly in a place where it was maybe 600 millimeters of air. That means that the drone has a diameter of 400 or 390 millimeters. You're so close to the water that it actually just blows up the water, making the whole drone wet, which is not a problem for the drone, but of course then you have a wet lens and you don't see anything, yeah, which is not a use for anyone. You can prove that you can fly there, but it's not actually useful data. So, well, yeah, I would set the limit to when there's water below 800 millimeters. When there's no water, you can go 100, 600 millimeters. Yeah, so those are the limits. And of course, the tighter it gets, the harder it is to fly quickly, so you don't cover that much length. I'm really sorry, I forgot the question.
It was about the sensors. I mean, is there any sensor like autopilot, something like that?
Yeah. So the Helios 2 has 7 sensors. I think if I get it right, or 7 pairs of sensors. It's a combination of infrared distance sensors and optical flow sensors used for the stabilization. So you cannot really compare it maybe to like a DJI drone that you fly outside, because that also has the advantage of the GPS stabilization. But yeah, of course, it's stabilizing itself. Still need a lot of manual corrections, but the sensors yeah, keep it like in a straight line. Also, when you fly or when you get in touch with the surface, it's not really a problem, because the drone is actually designed for like coming into contact. When you fly down the manhole or the shaft, it's basically impossible not to touch the walls. Yeah, that's why we use these highly specialized drones. They're specially made for this type of use.
So,
thank you. Just a little question. For example, in the channel, is there any, for example, ultrasonic sensor to measure the depths of water? I mean, in this 7 sensor, is there available too?
Not yet, but those are the topics of the future, I think. We're always in search of what can be done in the future. One thing is what you're mentioning, measuring the depth of the water, and by that also measuring the amount of sludge on the ground of a sewer. It's not possible yet, but I'm sure that that is something that the future will bring. Yeah.
Thanks, Dankeschön.
Thanks for your questions.
Is there any more questions before we wind this up? So, okay, if you guys have any question or if you want this presentation or the video, you can find it always in the YouTube. And if you have any more questions, if you want to ask the pilot or us or anything about the wastewater talk, you can contact us or you can contact Mr. Simon Kum. He also has a LinkedIn profile linked into this event. So if you guys want to reach him about the drone or anything else in the future, you can. He's always happy, and we are always happy to answer your questions. And so with that, I want to wind this up. Thanks again for coming and joining all of the participants and who are here for the first time. And thank you so much for coming and joining today. And I also thank Mr. Simon Kum for this presentation and his time for us to explain all this inspection and the technologies which is using about the drones and in the sewage canals. So if you guys interested in this, so next time it's going to be on 1st of December at the same time. And you guys are we are always welcome to see new faces and see new people and then meet many just to interact and have a discussion and which is useful for the technology and knowledge and building and everything. So and have a nice day, everyone, and thank everyone for coming. Bye-bye. See you next time.
See you.
Goodbye.
Thank you. Bye. Thank you.